All right, so for today's meeting, so for today's meeting, basically we're gonna be looking at time series prediction. So, I mean, what's time series prediction? Is basically you're trying to predict some sort of quantity that moves with time. So for example, stock prices, the stock changes as time or changes with time. So we're going to look at basically how you can do that with a neural network or a specific type of neural network called a recurrent neural network. So basically, I had this idea of let's see if we can predict stocks or stock prices or the trends in stock, the up and down trends of stock prices um, with the Jamaica Stock Exchange. I know it's something that they do in the US. So I was basically seeing if the same could be done with Jamaican stock data. So, I mean, the main index that deals with all the stocks is the Jamaica Stock Exchange. And here we have a lot of different companies. So basically the data looks more or less like this, where you have the volume of stock traded, so the amount of units traded on that day, what price the stock closed at on that day, and what the change was from the previous day and the percentage change. So I was basically looking to see if there was like a nice a nice something there format, CSV format that I could do some data analysis on. But to my surprise, I couldn't find any. I was looking around to see if there's any um, like actual data on this, and I couldn't find any. But I mean, the data is right here. And a lot of times as a data scientist, you're not gonna get the data in a nice format. So you're gonna have to do the work of actually, extracting the data yourself, whether that's from like a SQL database or sometimes even from a web page. So luckily there's a library called Beautiful Soup that you can actually use to scrape data from a web page. So this is actual web page. As you can see, there are 3 tables in this web page. So we have the stocks advancing. So these are the ones that actually increased in price from the previous day. You have the ones declining. These are the ones that decreased, obviously, and the ones that traded firm. So these are the ones where the price did not change from the previous day. So how Beautiful Soup works is that you basically give it the HTML document, and then you can parse the HTML document. So you can do things like find all the table tags, and then from that, extract all the P tags and stuff like that. So if you've ever seen a HTML document before, it kind of looks like this. So this is the actual HTML document for the page, right? If we right click on a specific element, we can see what the actual thing is. Yeah. So here we have, the part that says stock advancing. This yeah,
the JSE doesn't have like an API that you can get the data from
exactly.
either.
That's the thing. I was looking to see if there was something like that, but I couldn't. So yeah, I found that very interesting that there wasn't like a API or well, I'm gonna actually search again. JC stock API, XML API. Let me see this. It said persons interested in subscribing to this service, please submit a request to the JC marketing department. Lol. Let me see this. Submit a request. Your name, email. Okay. I haven't actually tried this before. Maybe this actually, let me see. It's XML API that is used to disseminate real-time market data, display real-time market data to the customer base, populate public data walls or website. So I'm guessing there is some sort of API, but I'm guessing you have to fill out some form. And of course, that might take forever for them to respond. But to be honest, I haven't actually tried this method. So I'll actually send an email and see how quickly they respond. From what I hear, it's you might have to pay for it. I'm not entirely sure, but I guess I'll see for myself if that's the case. But nevertheless, I figured why not just um, use this as a chance to, I guess, brush up on my web scraping skills, you know. Um, and plus this way I can format the data how I want and stuff like that. To be honest, it is a slower method than say if I had like an actual API, because then with this, I have to basically pull the actual HTML document for each day for whatever period that I'm doing the stock prediction from, and then parse each of those HTML documents. So of course, depending on your internet speed or whatever, that can take time. So let me just, I guess, walk through how I did this. So as I said, the data is essentially in this HTML document. So Beautiful Soup allows you to pass a URL, and then you can pull an HTML document. So you import Beautiful Soup like this. So I created this function called get data from date. So you pass in the date, and then it will basically it will basically pull this page here for that particular date. So if I wanted it for, say, April, let me see, let's say Wednesday, then it would basically using the same URL format here, go to this page here. And the good thing is that the page is basically formatted the same, more or less, for for each date. So it's not like I had any issues where, on the some other date the data was formatted differently or something like that. Anyways, let's look at the actual function. So yeah, first of all, you create the URL, passing the date as a string here. And this basically use a request library to get the actual HTML, right? And then basically what I did first was use Beautiful Soup to extract all the tables that had a certain class. And if you look here, all of these tables have the same class. So the HTML class. So I may inspect this one. Yeah, all of them have the same class. So basically, I use that to find all the HTML elements that had this class. So that's going to get me basically all the tables in the document. All right. And here I'm saying basically if there are tables, because on some dates, so for example, on weekends, there's no, because the stock market is closed on weekends and on holidays, you won't get any tables. Basically, there's no data for those dates. So basically, do this check first, make sure if there are tables, and I'm going to get the data from those tables. Let's go to that function here. So this basically takes in the tables, and it's basically going to extract the data from the table. So here I'm saying, all right, I'm going through each table, and then I want each row. All right, so TR is a tag for getting a row. So I'm saying for each row in the list of rows, then I'm going to get each cell, or basically get all the cells in a row. So let's look back here. Yeah, so these are the cells basically. So these TD tags are the cells. So that's the actual data that we want to get. Let's come back here. So I go through each cell and then extract the P tag. So the actual number is inside a P tag. I hear him saying, okay, if there is a P tag there, then inside that, I think there is a A tag. Let me just make sure. Yes, there's a A tag. Oh yeah, there's a A tag for the name of the stock, but for the other ones, let me see. Yeah, there's no A tag. So here I was just, this line here is just this is for the thing there. I should actually comment it. So that's the name of stock. Yeah. So this is for the name of the stock. But so yeah, if it's not the name of the stock, then it wouldn't have the A tag. So it would just look, it would just be inside a P tag like this. So if you look at all the other ones, they should just have a P tag like that. And here I'm basically saying if there's a comma in a number, then I basically just want to replace the commas with empty spaces. So I basically can convert it from a string to a number, because some of these numbers have like a comma. Because I want to convert to an actual number, then I just remove the commas and then convert them to actual number. So that's basically what these lines are doing. And yeah, and then basically extract all of that and then put them in a new table. So that's gonna return some tables. All right, so this is actual function that goes through and extracts the data for a particular period. So you put in the start date and the end date. So you can, if you want to use this notebook yourself, you can just modify the start date and the end date here. So here I'm just going from January 1st, 2019 to March the 16th, 2021. So a lot of this data should be around the pandemic time. Well, both 2019, so it should include data that was in the pandemic, because 2020 would be in there as well. So yeah, I use the date time library to create the two dates, start and end date. And then this is basically just gonna go through and create an array of dates between this date and this date. That's what this is doing right here. All right, so it's basically saying for each date, I'm going to basically pull the tables for that date. So I use the get data from date function to pull the tables from that date. I'm saying, all right, if there are tables, so if there's data for that date, then this function here is gonna return basically the stocks that advanced in a table, or in a list, I should say, stocks that decline, and the stocks that traded firm. Now, the thing with the traded firm stocks, this is again a part of when you're doing data science, you have to look out for things like this. You know, sometimes the data doesn't come in a certain way. Sometimes you have null values and all of these things. If you look carefully at the ones that traded firm, it's unlike the other tables. So whereas the other tables had four, was it 1, 2, 3, 4 columns, the stock traded firm table only has 2 columns, volume, close price. So I wanted everything to be uniform. So everything, because I'm gonna put everything in one table. So what I did here was basically filled out the columns, the 2 columns for the stocks that traded firm. So that's the price change and the change percentage column. Of course, if it traded firm, that means there was no change in price. So the price change should be $0 and the change percentage should be 0%. So that's essentially what I did here. So I'm saying basically for the traded firm stocks, I basically said I'm gonna add 2 more columns, and for those I'm just gonna put 0 for each of them. Yeah, and then basically I just returned. Oh, what I also did was add the name of the stock. to the table. So basically, after you run all of this, what I did was create a pandas data frame. So pandas is just a library that allows you to do data analysis. So you can read CSV files, read Excel sheets. It allows you to create what's called a data frame, which is basically just a table, and then you can do different things on that. So this is really just creating a data frame. So you give it the columns, and then you basically give it the array or the tables in that sense. And this will just basically create a table. So these are the columns. You have date, you have the name of the stock, how much stock was traded on that day, the close price, the price change, and the change percent. So after you run this here, as you can see, it prints the date for each date it's getting here, just so you can see where it's at. So these are all the dates it got stocks for. So after all of that, you should end up with this having some value. So this should be a data frame with all the stock data from 2019 to 2021. So you get something like this. So df.head, this basically just shows you the first 5 rows in this table. So this is just an example of how the table looks. So as you can see, we'll have the date column here, having the dates. We'll have the index. So these are the stock names. How much stock, the volume, the close price change, and the change percent. So what I did here was, all right, let me just pick a stock and see if I can somehow predict the stock trend for this for a particular period, right? So I said, all right, let me pick out Grace Kennedy. So this is how I got Grace Kennedy. So basically you're saying just extract all the rows where the index column here is equal to Grace Kennedy. So I stored that in a separate table. Did this to see how the table look. So we should end up with in this table just basically the stock prices of Grace Kennedy throughout that period. So basically the important column to look at here is the close price. This is how the stock changed throughout the period. I just did a length here just to check how much rows we have. So that's 555 rows. And then I plotted it. So this is basically how the stock price changed over the period. I'm guessing this dip right here is maybe through that 2020 pandemic period, but obviously Grace Kennedy is starting to do well again. It's going up. That's good. All right. So basically, I wanted this in a nice format, or basically store it in a file so that maybe even other people can use it. What I'll do is actually put this in the group. So you guys can, instead of having to go through this hard part of pulling all this data, because it takes a while to pull all this, you can just go straight to using pandas to read from the CSV file and do your own data analysis. Maybe you can come up with a more accurate model than what I did. I mean, what I did was pretty basic, and I mean, I guess you'll see down here. So yeah, so as you can see, 555 rows, 6 columns. All right, so what I basically did is I'm gonna extract the close price column. So this is basically the column that has the stock price. So that's essentially what I'm trying to predict for a particular period. So here I just extract all the close price values. So this will basically create like a NumPy array. What I did here was reshape it. So basically it would have the shape of 555,1 instead of just 555. Instead of a flat vector, it's a 555,1, so like a matrix. Anyways, all right, so basically anytime you're doing any type of machine learning, you need train and test data. So basically what I did was the first 450 values, I'm gonna use that for training data. Everything after 450, so I guess that would be 100 and something. That would be for testing. So I want to see how well the model can do predicting those values. All right, so usually after you gather your data, what you want to do is pre-process the data. So sometimes, well, a lot of times when you're dealing, especially when you're dealing with neural networks, it's better if the values that you're working with are small. It makes learning a model a lot easier. So, and you see this a lot anytime you're doing any form of data science. Anytime you get some data, you'll usually see something like this, where they'll basically scale the data. What this is basically doing is basically taking all the data and then converting everything to one scale. So we don't want the case where we have some values having very big values in the table and some columns having very small values. What that can do is basically give one columns, some unfair advantages. And as I said, it works best when the values are small. So this will basically, in layman terms, just make the values pretty small. So instead of these big values like 60, 80, which can basically make learning very unstable, you probably end up with like some small values like 1, -1, 1 point something, 0 point something. Yeah. So I use a standard scalar. This is in the scikit-learn. So some important packages when you're doing data science: pandas, definitely; matplotlib for like plotting data. Of course, if you're doing neural network stuff, TensorFlow, of course; NumPy, definitely; and sklearn. This is probably the most important library you'll use in data science. Yeah. So basically, I'm gonna transform the data, the training data, transform the values. All right, so basically now I want to be able to predict the stock price. So essentially, how this is gonna work is that I'm gonna basically be using a history of the stock price up to a certain point. So we'll call that the window. So in this case, our window is going to be 40, or the previous 40 values. I'm going to be using those previous 40 values to predict the next value, so the 41st value. So just imagine you're trying to predict the stock price for tomorrow. What I would do is take all the stock prices for today and the previous 39 days and use that as a guide to figure out what's the stock price for tomorrow. All right. So this is my window length, essentially sequence length. Essentially, what I'm gonna be doing here is basically from my list of values, I'm gonna be creating a set of um, sequences, right? So the first sequence would be the first 40 values. The second sequence would be from value 1 to value 41. The third sequence would be value 3 to value 43, and so on and so forth. All right, so that's essentially what I'm doing here. So I'm just getting sequences of values of length 40 throughout my data set. So yeah, remember with machine learning, you have your X, you have your Y. Your X is your input data that you're going to do some prediction with. So your features essentially, and your Y is basically what your target is or what your output. So in this case, our Y, in this case, is the 41st value, as I said before, and the X would be the previous 40 values. All right, so create NumPy arrays from that. And as you can see, this is the shape of my X and my Y values. So as you can see, the Y, as it usually is just gonna be a list of values. So each of those, essentially, each of those 410 values represent the prediction for each of those periods. So this here is basically the sequences. So it's basically saying we have 410 sequences of length 40. All right. And then for each of those sequences, we're predicting the stock price for the next day. All right. So what are we going to use to do that prediction? So in machine learning, or in neural networks, we have something called a recurrent neural network. Recurrent neural network is used for time series prediction. So the whole idea is that we have something called a hidden state. It's basically a vector that basically tracks the history of the neural net. So basically, the input to the neural net is the previous hidden state plus the current input. So as I said, the hidden state is like a history of the previous inputs. So you use that plus your current input to make a prediction for the next output. So that's basically how a recurrent neural network works. So we're going to use a special type of recurrent neural network called a LSTM. So LSTM is just a modification on a recurrent neural network that allows it to solve some problems that the original recurrent neural network had, such as the vanishing gradient problem. So basically allows it to learn longer temporal sequences by essentially allowing the neural network to forget the unimportant things and just keep in memory the important things. So you can remember with longer and longer periods. All right, so here I'm just saying, all right, so this is just how many units I'm using for the LSTM. And this is just input shape. So this is just saying our thing is sequence length of 40. So it's 40 stuff, all right? And each thing is one value. So, all right, so basically there are 40 values that we're using as a sequence. And then the output here, this is the output layer, is just a dense. So basically it's just gonna output a value, one value. In terms of the loss function, we're gonna use a mean squared error. So basically that's just gonna calculate error between the predicted and the target. So remember, the target is the actual value for that day. The prediction is what you're gonna predict using the history. And the mean squared error is just gonna take the difference between the two, square it, and then the neural network is gonna use that error, so the difference between the predicted and the target, to calculate gradients that's gonna basically use something called back propagation to update the values or the parameters of the neural network so that it gets better and better at making predictions. So anyways, we compile a model so using the Adam optimizer mean squared error, and then we'll pass in the training data, the targets, batch size 1, number of epochs. So after we train, it's now time to actually test. So what I did first of all is to transform the test data, of course, and I did the same thing. So here I'm just basically creating the test data. Do the same thing I did here, convert them to NumPy array, and then I use a model that evaluate function here to evaluate this. I'm not sure of the actual, I'm guessing you use the root mean squared error metric, right? To see how good the model is. So basically the lower this value, the better your model. So here I'm essentially just, what I did is I'm gonna predict the stock value using this. So the 105 days we have here. All right. So yeah, I did that. So calculate the Y-pred. But because we're using a sequence length of 40 instead of 105 days, it would be 65 because we're gonna use that first 40 for the first day, and so on and so forth. So you end up with, so we're just basically predicting 65 days worth of data. Yeah, so here I'm basically gonna plot what the predicted stock values were and the test, these are the actual stock values. So I did an inverse transform. So basically, remember we transformed it here. Inverse transform basically transforms it back to the original values. So I just use matplotlib, and this is what I got. As you can see, the trend lined up pretty well going up. So this is actual stock data, and these are the actual prediction. As you can see, it's actually predicting pretty well up to a point. But here, when you had this large spike, I mean, you can see the model kind of going up as well, but it didn't predict that large spike as well. So you might be asking, all right, why didn't the model do that? You know, why didn't it predict that huge spike? There could be several factors. One big factor is that we're only using one feature to kind of make prediction on the stock price. So we're literally only using the stock prices of the previous 40 days. When you're actually creating actual models that do stuff like this, like predict stock for like, the people that actually do this stuff, there are several different factors that go into predicting the stock price. It's not just looking at what the stock price was for previous days. I mean, if that was the case, then there'd be a lot more billionaires. You'd have to look at things like news reports, when companies release their financials, all sorts of different factors that could go into play into predicting stock price. So if we were really serious about really predicting the actual values and stuff like that, then we could do stuff like pull news reports, do something like sentiment analysis, kind of see if there's sort of people are feeling bad or good towards a company, and then kind of use that to help predict price. But the point is, there's never gonna be a perfect model that does like really predicts it perfectly. If that was the case, then there'd be a whole lot more billionaires. But these methods are used in like actual companies and stuff like that. But as I said, definitely it's a lot more complicated. The ones they use in terms of they'd use a lot more information to help predict the stock price. But yeah, this was Grace Kennedy. I think for another stock where there wasn't this big spike, it actually lined up pretty even with the line. So you're probably wondering, all right, from here, what can I do? Like in terms of can it predict, can it forecast going onwards? Yeah, you could use the predictions that the model makes as inputs to the model. So you can essentially forecast it out for as much days as you want. Problem with that is because it's using the model itself to create that input data. It's probably going to be very inaccurate. That forecast. Yeah, because before we were actually using actual data from the stock price to predict the price for the next day. Now we're basically saying, all right, we're going to be using the predictions as the history of the stock price, which if the predictions weren't very accurate, then the difference between the actual thing and the real thing is going to be way off. But anyways, yeah, this was just a kind of short introduction to some time series prediction. Um, you know, extracting data from the JAIA stock website using beautiful soup, scraping the HTML, creating a CSV with some tables with the stock data, doing a plot, creating a LSTM to predict the stock price. Yeah. So yeah, my advice is to check out Kaggle. There are a bunch of like people that do like some more complicated things like stock analysis and stuff like that. So if you're interested in like time series analysis and like stock data and stuff like that, and financial using machine learning for financial stuff, then I would advise you to go on Kaggle, just type in whatever you're looking for, like stock data or stock prices or whatever. And there are usually like some notebooks where people actually go through that. In general, I don't know if I've mentioned this before, but yeah, I recommend checking out Kaggle. So Kaggle is like the hackaround for machine learning. So people post like data sets, and then you can basically compete to like create a model that has the best prediction. Yeah, and sometimes companies actually post up real money, so people can win actual money, or companies actually hire from people that compete on Kaggle. And if you look at like if you're not comfortable actually starting or competing, you can actually just download the data sets, just play around with it. You can look at other people's notebooks. You'll find that like most people generally use the same strategy on most data. So there are certain models that tend to work pretty well for certain data. So, as the more you do it, you kind of know what strategy right away to use. But yeah. Any questions?
Well, not really a question, but well, sorry, this is a question. Like, why the model that you used only had like two or
Mm-hmm.
so layers, right? Why did you choose such a
Mm-hmm.
small model?
Well, I mean, it depends because I actually tried using multiple layers. Well, more layers than what you had here, and the model wasn't as accurate. The thing about using more layers, um, there is a drawback to that. It can overfit, meaning that it only memorizes the training data but doesn't do well on predicting test data. So if you're going to create like models with like a lot of layers, it's important that you have like a lot of data. Considering I only had like 400 rows of data here, really and truly this is a big enough model for predicting what that is. If I had more data, more features working with and stuff like that, probably I would have to use more layers. Generally for LSTM, you I don't think you'd sim over 2 layers of LSTM layers. So yeah, generally you don't use. What you could increase is this, but even then, like as I said, I tried it with more, and it would still, and it didn't perform as well. Um, the meeting time is about to run out, so if at any point in time you see like it the meeting kind of chips out, just click back on the link and it will let you back. But any other questions? But my advice, you can play around with this notebook. I don't know if the link I sent you allows you to edit. Even if it doesn't allow you to edit, I think you can save a copy in your Google Drive, and you can play around with this, change the values, and see if it gives you a more accurate value. So this should go down if it's getting more accurate. And I guess you can look at the plot and see if it's close or whatever. You can try getting more data. So I only use what two years worth of data. You could yeah. So as I was saying, I only use what is it like 2 years worth of data. You could use more. But yeah, but again, the thing is like as I said, just using the stock prices alone isn't gonna be enough. To be honest, there are several factors that lead into stock prices. Sometimes you can't even predict these things. Who could predict that there was gonna be a pandemic in 2020, right? Stock markets was basically at its highest in 2019. It was booming. And all of a sudden in 2020, basically every stock just plummeted, literally, on that between that March to June period of 2020. Yeah, a lot of stocks got hit that day or that period. I mean, some stocks are still in a rising again, especially like manufacturing, distribution stocks. People want food and stuff like that. So yeah, some stocks are coming back. So yeah, hopefully that remains the case. I'm no expert on time series prediction and stuff like that. I'm sure I mean, of course, there are other methods that I did look into. I found the LSTM one to be most accurate. So just to kind of, I guess, show you some other methods that, so that you can maybe even look into it. So there's a moving average method, k-nearest neighbors, linear regression. And I guess I'll probably just send this link in the group so you guys can try it out for yourself. But yeah, that's about it. Any questions or any more questions?
No, not from me.
Okay. But yeah, I mean, generally, I've been thinking like, how can, we apply what we're learning, in a practical way or stuff like that. So, I mean, there are a lot, as I said, um, or as I've mentioned a lot of times, the big companies are working on problems. Those problems are not necessarily our problems, but we do have problems. So problems that are specific to, third world countries or Jamaica or whatever. So we can use a lot of the algorithms models that are created and, use it on our data, the data that we produce. I mean, a lot of that is gonna depend on, good data gathering initiatives taking place or being set out. Um, I know that some initiative like that has been started. I don't remember the name of the organization, but there's a name of organization that deals with like gathering data on different things in the Caribbean. But yeah, something that I'm meaning to kind of finish is the Patois bot. So maybe I'll do that for next week. This time I'd probably get the data from Twitter, so it'd probably just extract, you know, uh, tweets from Jamaicans. So more likely there's gonna be a lot of patois, and then see if it can create like a language model. So output its own patois. See how well that does. All right. There are no more questions. I already sent the link to this in the group. I guess that's it. All right, guys. I guess next week we'll I don't know. I'm not sure what we're gonna do next week, but I guess we can think of something, or maybe discuss some paper or some new thing that came out the other day. I don't know.
Okay.
Have you heard about anything new this week in machine learning, or have you read anything new that came out, or
Um,
anything new that's interesting? Are you familiar?
um, I was, this isn't new, but I was reading something on speech recognition.
On what?
Speech recognition.
Oh, cool, cool.
Yeah, it's
Um,
nothing new though. It doesn't use like transformers or attention or anything like that. It's just
mhm.
LSTMs. I
Yeah.
think plain LSTMs.
Okay. Yeah, something I've actually been thinking of, um, like speech recognition for like, patois speakers, like, Jamaican language, kind of see how that would work. I'm guessing the biggest problem with that would be the data. Yeah, but that would be interesting if that could be a thing, or if we could do something like that. I
Yeah,
guess.
I've been thinking about that because like
Mhm.
the patois isn't like as far as I know, well at least how it's
Yeah,
spoken, it's not standard.
yeah,
So
that's the thing. Yeah, yeah,
like you have people here speaking one way and then Saint Elizabeth, it's almost like a different language.
yeah. True, true. Yeah, there isn't a whole lot of structure, which is definitely why definitely some data-driven approach is gonna be needed. It can't be something where you're trying to use regular like grammar rules to develop some sort of structure or whatever, like how they did it back in the past. But yeah, that would definitely be interesting to see how that would work. I guess we can look into that too. All right. Let me see. Is there anybody else here? Uh, oh, all right. I think that's it. All right. I guess next week. All right. Um,
All right,
yeah.
cool.
Bye.